This is Viterbi Voices, your chance to hear stories about research, classes, student life, and more.
Directly from our students, faculty, and other members of our engineering community. All right here at the USC Viterbi School of Engineering.
Hey everyone, welcome back to Viterbi Voices. My name is Paul Ledesma, Director of Undergraduate Admission here at the USC Viterbi School of Engineering.
And my name is Audrey Roberts. I'm a senior studying mechanical engineering here at USC.
And we just keep popping up with surprise episodes over and over and over again, and we ain't done yet. This is our next surprise bonus episode with a faculty roundtable discussion featuring the faculty of the Astronautical Engineering Department. Audrey, I know you're excited about this one.
I am excited about this one. I love the Astronautical Engineering Department. I'm in the AME department, tangent to that one, but I think it's a good one.
There's lots of overlap with aerospace, mechanical, and astronautical engineering students, and I think that's one of the main things that gets discussed here and our previous episode with aerospace, mechanical engineering, is that our high school students and transfer students are worried about which one's the right one for them. And so, I mean, can you put it to rest? Like, it's just pick the thing that sounds the coolest and you'll figure it out?
Yes, you will learn what you need to in all these majors. A lot of the classes have crossover and there's a ton of flexibility too. Like, for example, I'm taking some astronautical engineering courses this semester, but they're counting for my AME credits. So
as a mechanical engineer, right? So it's people, and there's so much in the Q&A in these, as a spoiler alert, that gets into like, what's the best one? And you all get the same jobs, you all work next to each other. It's just a question of what sounds interesting to you, of things you want to work on in your classes. I think Dr. Spedding talked about this in the Aerospace Mechanical Engineering Roundtable, and that gets discussed again here in Astronautical Engineering. But we also have some pretty biased sources here. Astronautical Engineering is the chair of the department, Dr. Dan Irwin, the previous chair of the department, Dr. Mike Gruntman, and former astronaut and SpaceX executive, Dr. Garrett Reisman. Really cool conversation. We talk about the view from space. We talk about what they create in space. And we also talk about why Dr. Gruntman's Zoom background is the moon, and he calls it his backyard. So just lots of fun, cool stuff. Let's get out of the way and dive right into some really, first of all, word of warning, Dan Irwin has a really dry tone, okay? But don't be dissuaded by that, because there are some super funny gems that he lands, and you have to know Dan Irwin to know that he's going to lay those out. But in your ears, it might feel like, oh my God, what am I listening to? But Dan is super cool, and just you get used to it, and it'll be super, super funny. Welcome to the USC Viterbi School of Engineering faculty roundtable discussion for the Astronautical Engineering Department. I'll be your host for today's event. My name is Paul Ledesma. I'm the Director of Undergraduate Admission here at the USC Viterbi School of Engineering. We have a really cool hour set up for you. And before we get into the introductions, I want to go over a few ground rules for today's event. We have a lot of you here. And so here's how we're going to go. First, we're going to have the faculty introduce themselves. We're going to discuss some things about our program. We're going to talk about the curriculum. We're going to talk about research. We're going to talk about what it's like to be an astronautical engineer at USC. And then towards the latter half of the program, then I'm going to open it up to Q&A. So what I will ask you is to please hold your questions. And before I even had the chance to do that, one of you already asked a question. So go ahead and hold your questions, please. I think a lot of the questions will be framed by our discussion. When I give the green light, I will allow you to go ahead and ask questions using the Q&A feature. But please, I'm going to hold back from that for right now. And without further ado, let's get directly into our faculty. And I think we might even have one joining in a few minutes, but let's get started first with Professor Irwin.
Hi, everyone. Thank you for coming, and thank you for being interested in USC Astro. I'm Dan Irwin. I'm professor, and I'm actually chair right now. Not forever, but I'm chair of the department. I was an undergrad at Caltech. I was a grad student actually here at USC in electrical engineering, and then I joined USC in aerospace engineering, doing hypersonics, and we kind of transitioned over. I hooked up with JPL and started doing electric propulsion, and gradually my work kind of went over to Astro, and so here I am some years later. By the way, Garrett Reisman will be joining us in a couple of minutes.
Just found him. We're bringing him in right now. Professor Gruntman.
All right, welcome guys. I'm Mike Gruntman. I'm professor of astronautics. I'm actually, I served together with Professor Irwin. We sort of swapping the positions of the chair from time to time. I was, a few years ago, I was chair, and I was also like 15 years ago, I was the founding chairman of the department when we were established at USC as a specialized space engineering department, in contrast to space classes or space specializations within the aerospace departments. And later we can talk about the reasons for that. And I also would like to mention that Professor Irwin is the real guru on our undergraduate program. So he not only a chairman of the department, but he also directly manages our undergraduate program. I am to a significant degree in a direct the master's program in the department. So we complement each other, but both of us were involved in all areas. So just we will be we're here to answer any questions and talk about the department. And I also would like just to mention that we really provide education because I saw the first question and the only question already was typed. Is it okay if I don't know how to code to become a student in astronautics? And the answer is absolutely yes, because coding, it's training. You can just train anybody to code. But to understand the basics of science and engineering, you need education. And that's what we are here for. Paul, back to you.
Thank you. And Professor Reisman, we found you in the attendees section. I'm sorry about that. Thank you for joining in. But please feel free to introduce yourself.
No problem. It's my pleasure. So I'm Professor Garrett Reisman, and I'm relatively new to the department. I've only been on the faculty for a couple years now. I teach graduate courses in human spaceflight, and I have 3 different courses: an intro course, an ops, a life support system class, and then a human factors class. And I know you're all potential undergraduates, and I wanted to point out that there is opportunities for undergraduates to take my courses when you become a senior. So with permission, you can take graduate courses at that point. So I hope that one day I see some of you in my classes. Prior to becoming a professor at USC, I was an executive at SpaceX. I was our director of space operations at SpaceX. I joined SpaceX back in 2011 and worked extensively on all of our human spaceflight programs there, including the Crew Dragon and even a little bit on Starship. Prior to that, I was a NASA astronaut. I spent 13 years as an astronaut at NASA, flew 2 missions on the space shuttle, including spending about 3 months, 95 days on board the International Space Station. And so prior to that, I was at TRW as a guidance navigation control engineer. And prior to that, I was did my graduate work at Caltech and my undergraduate work at University of Pennsylvania. So be looking forward to taking any of your questions, and hope to meet all of you on campus someday in the future.
This is great. As you can tell, everyone that's watching, we have an all-star panel lined up for astronautical engineering. And I'm confident there's a joke in here somewhere. An astronaut, an electrical engineer, and a professor walk into a bar. I think there's something that we can probably devise somewhere in this group. We'll come up with that solution later. But as we said earlier, we're going to talk about the curriculum, the undergraduate program, research, outcomes, etc. And then as we get towards the second half, I'll open up Q&A. And so thank you for being patient as we get into this session. So without further ado, I think the one thing that I want to make sure that we talk about is let's open with a seemingly simple question, but probably a more of a complex answer. What the heck is astronautical engineering?
Okay, I can take that. Okay, first of all, you can if you kind of look broadly at engineering as a field, of course, it's all technical areas. We work on different kinds of things. Electrical engineers work on things which center around electric circuits and electronic, like large-scale integration, computer processors and so on. Chemical engineers, that process plants, refineries, and so on. There's a group of majors, mechanical, aerospace, and astronautics, which are kind of the same down underneath. We all view the world from a sort of a mechanical point of view. Now, mechanical is very general. So a lot of mechanical engineers end up working for car companies, but every industry employs mechanical engineers. You can think of aerospace engineers as mechanical engineers who emphasize flight vehicles. They study aerodynamics, stability of flying vehicles, um, uh, fluid mechanics specifically for subsonic and supersonic flight in the atmosphere. And you can think of astronautics as mechanical engineering, but kind of specialized in rocket vehicles and space vehicles. So for us, we don't use the atmosphere as a kind of a lifting body, except occasionally when we come in to land on Mars. But for the most part, the atmosphere just sort of gets in the way for our rocket vehicles. Actually, if we didn't have an atmosphere, we'd launch horizontally, not vertically. The vertical launches, we only do those to get through the atmosphere as quick as possible. The majority of the work is for orbiting spacecraft and spacecraft which go into deep space. For example, the spacecraft that study the outer planets. So, uh, so basically, autonomous systems, rocket propulsion, um, manned and unmanned space vehicles. That's what astronautics is about.
All the fun of aerospace engineering without that annoying atmosphere getting in the way. I love it.
So if I can now follow up just a little bit on what Professor Irwin said. So regular aerospace departments, well, let me start historically, where we are in the United States in aerospace and space education. So historically, in 1930s, the first departments of aeronautical engineering were established when the aviation industry began to grow. And when the space age began in 1950s, then space engineering rose, and the home that space engineering found was within aerospace departments. Aeronautical departments changed their names to aerospace or aeronautics and astronautics, and the space engineering found home there. So what happened since those years, it's a very broad area, aerospace. So, and as the space field were growing and became more and more specialized, it turned out that aerospace departments still dominated and focused on the aeronautical part of aerospace. That means related to airplane, if I simplify a little bit. So, and there was a lot of not complaints, but the concerns in the space people in the industry. And when I'm saying industry, it's also government research and development centers focused on space. Those are that are in the Air Force and in NASA centers. So we realized at USC that we can establish a pure space program to meet the needs of the industry. And the biggest program that we have and had from the very beginning is on the master's level. And it turned out that when we established the pure space department 15 years ago, our program skyrocketed, pun intended. Master's program just became one of the largest in the country. We're a comprehensive department. We have a PhD, we have an engineer program, and we have obviously a very vibrant undergraduate program that Professor Irwin would tell you more about that and classes. But so we did the right thing at the right time. The space industry today worldwide is $350 billion, and it has been growing for the last 15 years, about 6 to 7% per year. Recently, there was a tremendous surge in the new commercial entrepreneurial ventures in space. And many of them are driven by computer people, well, people with money in the computers, as you know, and by electrical engineers and others. But the core expertise that is needed for any such venture going to space is what astronautical engineering provides. These are pure core areas focused on various parts of the space technology. They are indispensable. Without them, no computer engineer, no electrical engineer, no chemical engineer would be able to build the systems and operate them in space. So we provide this core competence.
Thank you for that. That's fantastic. I think that provides a lot of background to our students, especially as they're trying to navigate where they want to go. let's dive in a little bit more. Maybe start with the 30,000-foot view of what is the undergraduate curriculum like in astronautical engineering? What do students learn, and how will they progress as they go through this program?
Okay. Well, in the very first year, the very first semester, we have an introductory course, Astro 101. Most of the engineering majors have an introductory course, which kind of introduces them to the whole field. And actually, I'm teaching that right now. So if you come next year, I'll probably be teaching it again, and so you will have me in person, I hope. But it'll be online if I have to. We're online this year, of course. But so in the freshman year, you learn what space is all about, what it's for, a bunch of things about it. Plus, you learn a bunch of skills, how to use different kinds of software systems, for designing and visualizing space missions, software for designing 3D um, making 3D computer-aided designs, and general programming work. And actually, the question about coding, we assume that you don't know anything about coding. In fact, in the class of about 35 people this year, about half of them have had prior programming experience. Programming we don't think of as an academic skill. We just think of it as a skill, like a technical skill, like using a drill press. It's something that you will probably get good at as an undergraduate. Um, Now, the first couple of years in mechanical, aerospace, and astro are mostly the same. The key courses that you take are in calculus and physics as foundations, but also the basics of mechanical engineering, which is statics, dynamics, strength of materials. And also, toward the end of the second year, you usually take the first introductory course in astronautics that's kind of serious and mathematics based. And actually, I teach that one too. That's Astro 280. And that one, you learn in some detail about orbits and propulsion, spacecraft attitude, um, as well as some kind of underlying mathematics that are extensively used in mathematics. I'm sorry, in astronautics, and not necessarily so much in other places. Then in your junior year, there's a 2-semester course in spacecraft design, which culminates in a team project design for an actual spacecraft. And there is a series of other courses, some of which are tech electives. You have a little choice in the curriculum. Some of which are aerospace and mechanical courses. In your senior year, there are a few more Astro required courses. There's the capstone design course, where again you work in teams and design a complete space mission. And that course is reviewed by industry experts, and it's in the second semester of your senior year, and it kind of builds on everything you've learned all the way along. There's also dedicated courses in rocket propulsion and spacecraft attitude dynamics. And as I mentioned, you're expected to take a series of tech electives, which if you take them during your senior year, you can actually take 500 level, that is master's level coursework. Because if you go and look in the Astro section of the catalog, which I recommend you do, you won't see a huge long list of undergraduate courses because our major is not all that huge. So we don't have room for 20 electives. But on the other hand, if you look at the master's level, as Professor Gruntman said, we have a very large, the largest master's program in astronautical engineering, and we have an unmatched list of master's courses, which are specialized courses in spacecraft technology, typically taught by people with decades of experience. So, and you are free to take those as undergraduates, as technical electives. And in addition to that, quite a few of our students decide to go on and become master's degree students, pardon, and either in an ordinary sequence or as the so-called PDP program, the progressive degree program, where they do their senior year and the master's program, maybe with an additional semester or two, basically at the same time. So, to summarize very quickly, it is like the mechanical engineering program, but with a considerable degree of specialization in astronautics coursework, which culminates in several spacecraft design courses.
Thank you for that. I think that was a great overall summary. I put a link for everyone to review it a little more carefully in the chat. And the one thing I would want to tell everybody is that when you're really going through this in the admission process and you're coming through this whole coming out of high school and figuring out what you want to do, aerospace, mechanical, and astronautical, they have a lot of overlap in their undergraduate coursework. And so what I would want you to think about right now is, do you have to have the right answer of which one you're going into? Not necessarily. Go for the one that sounds the coolest to you. And of course, today, the coolest one is astronautical engineering because we got these faculty here. But as you go, if you find out that one is not right for you, switching to another is not a problem. You're never locked into any of these programs. So really, it's about figuring out which one you want to start in, because you can end in any of them. And I think that's the most important thing I want to get into. Can we talk a little bit more specifically about hands-on projects? I mean, we have a lot of hands-on work throughout the curriculum. Are there any favorite examples you have as you go through our undergraduate coursework of how students will be actually getting their hands dirty?
Okay, well, we can think of two pieces of that. One is the required coursework, and I actually forgot to mention the substantial laboratory component during the curriculum. And during your junior year, there's a 2-semester laboratory course. It's called Mechoptronics, and it is extremely valuable because in there you learn how it is that electronics and computers interface with the real world. Because you can only go so far with computers. All they do is think and do computations. But at some point, they have to actually be able to read what the outside world is doing and output information that's used by machines to do things. Because, of course, real world, starting at the large end, actual automated production plants, and going to the small end, things as small as these palm-sized quadcopters that you see, there's all kinds of autonomous or semi-autonomous devices that are controlled by computers, but there's an interface between electronics and the mechanical world. And in that class, you learn how to do laboratory experiments and how to control the mechanical world with electronics, how to both sense what the world is doing and influence the world with motors and actuators, which is really how physical engineering is done. And then in your senior year, there is a projects course, which is typically done in teams. This is separate from the capstone design course. This is an actual experimental project where you have an idea for original experimental work and you carry it out in one semester. Now that's all the required coursework. There are a number of extracurricular projects. Every major has extracurricular teams, but in astronautics we have one in particular that's got a lot of attention. It's the Rocket Propulsion Lab, RPL, where the students design, build, and launch rockets. So far they've all been solid propelled rockets, but they're starting to move into liquid propelled rockets. And they started actually 15 years ago, about the same time as the department started. And their goal has been to be the first student group to get to space with an entirely student-built rocket. And it took them many years of trying and bigger, better, lots of failures, learning from all the failures. And then finally, last year in the spring, they did it. They actually got to 100 kilometers altitude, recovered the rocket vehicle. So they broke their own world record, and they're now the first student group to actually get to space. So now they're looking for future challenges. And so that is the biggest student group within astronautical engineering. But there are a whole bunch of other hands-on groups all across engineering, and they're all interdisciplinary. I mean, Rocket Lab, for example, uses a lot of computer science people, a lot of aerospace, a lot of mechanical. There are even people from across the university. At some points we've had German majors just come along and they want to see what all the buzz is about, and they've actually come in and helped us out. And this is true for all the hands-on student groups. And even though they're totally voluntary, you can do them or not do them, but I highly recommend that you get involved with at least one while you're a student, because these groups, first of all, they're a ton of fun. Second of all, they're social groups as well as technical groups. So, especially if they're people that are sort of similar to what you're doing as a major, you can wander into the rocket lab and there's probably people working on the same homework that you have due in a day or two. And there'll be maybe somebody who took me or some other instructor the last year, and they'll kind of look over your shoulder and say, oh, actually, here's what he's looking for. Here's the trick to that one. And, you getting together and working together on stuff is a huge boost to keeping you involved and interested. And in, companies look for experience like this. Having experience in Rocket Lab or actually any of the hands-on student groups is a huge boost to getting internships during the summer while you're an undergraduate and to getting permanent job offers once you graduate. So a few years ago, there was a kind of a leaked document from SpaceX that was phrases to be looked for on a resume to kind of when you pre-process a student's resume, they look for phrases which kind of bring the resume to the front for kind of enhanced consideration. And one of the phrases was USC Rocket Laboratory. So that tells you something.
Yeah, so if I could add just a few words. So in addition to the Rocket Propulsion Lab, which is primarily undergraduate students, and most of them join as in their freshman year, and then they grow. It's self-governing, and the leaders are self-selected by the students. So it's tremendous for the resume, as Professor Irwin explained. There's another major group in the department is liquid propulsion laboratory that builds liquid propulsion engines. It may be a little bit, it's a different, but maybe to some degree more technology requires more mature students. It's dominated by master students. However, a number of undergrads in their junior and senior year joined this liquid propulsion laboratory, particularly when they got exposed to the propulsion coursework and I actually teach the course both for seniors and grad students on the rocket propulsion during the last several years. So there's a tremendous opportunities, as Professor Irwin said, and it's important to find something that you are passionate about, and then it will be really very cool. I also would like to mention that although today we don't have courses in the human spaceflight on the undergraduate level, and Professor Eastman mentioned that you can take those graduate classes, but chances are that by the time that you rise to the senior level, we will have perhaps a 2-unit course in the human spaceflight for our seniors in the technical elective.
I'm glad you brought that up because I wanted to pivot to Dr. Reisman and talk a little bit about his coursework as it's available as a technical elective and what's involved in that course. How often do they get to go to space in this class?
Well,
kidding. I'm sorry.
Yeah, that's an advanced
I
elective.
didn't know because actually some of them did go. Oh, I'm sorry. I'm probably disclosing something that I shouldn't.
I'm not sure what you mean by that, but first of all, in the interest of equal time, I want to point out that not only do we have a solid rocket propulsion club, and a liquid rocket propulsion club, we also have a nuclear thermal propulsion club as well. So we leave we don't want to discriminate against any form of propulsion. They're all represented. So as far as my courses go, the way I came up with my topics that I teach in the curriculum is basically, it really was based on my experience at SpaceX running this operations group. What I found was that when we were starting to work on human spaceflight, it was very easy in some areas to find people with very good academic preparation to hit the ground running and make contributions at SpaceX in a wide variety of disciplines. So if we needed somebody that to do some coding, we can get somebody straight out of a computer science program and they could write C++ or Python or whatever. If we needed somebody to do some loads analysis or do finite element modeling, again, we could take anybody straight out of undergrad. They knew what to do. But if we needed somebody to design a life support system or a spacesuit, or for that matter, to operate a spacecraft from a mission control center, nobody knew how to do that. We had to teach them basically from scratch, and they had to learn everything on the job. So that's how I came up with my courses that I teach for our master's students, which is the idea that if you take all my courses and if you went back in time and started working for me at SpaceX, you'd be able to contribute to my group on day one without having to first go through months and months of on-the-job training. So that's really the story behind how I put this together and why I put it. So that's how I put it together. Why I put it together is because you can actually go get a job now doing these things. When I was your age and going as an undergraduate through my engineering curriculum, if I wanted to get a job designing a life support system for a human spacecraft that was going to launch people from Earth into space, there wasn't an option. There was really nobody doing that. There's some R&D projects at NASA, but really nothing that was going to lead to anything that would actually fly. Now today, there's tons of opportunities. There's spacecraft being developed all over the place. We got Orion being developed by NASA and Lockheed. You've got the SpaceX Dragon. You got the Boeing Starliner. You've got the Virgin Galactic Spaceship Two. So and Blue Origin, I left them out with New Shepard, and they're working on New Glenn now. So there's a whole bunch of opportunities to go out there and take what you learn in my classes and actually go do it for real. And because the time is right, this industry, as was mentioned, is really growing, and the opportunities, I think, will only increase going as we go forward into the future. And so that's how I came up with my curriculum, and that's also why I came up with it.
It also provides me a great transition period. I neglected to share the results of the original poll, and so I'm sharing that now with everyone. People from all over here today, and why they want to be go interested in astronautical engineering. There's about 37 of them in today's audience that are thinking about being an astronaut. And considering you're an astronaut, what would you tell high school students that are looking to be an astronaut?
Well, I would point out that, at NASA, we have a great dental plan. They cover preventative visits as well. No. Look, it's a great gig. What can I tell you? Flying in space is fantastic. I can't think of anything that's really compares to that. In fact, one of the most difficult things I ever had to do was stop being an astronaut and go work at SpaceX. But I did that because I really believe strongly in the opportunity that it represented and the potential that it represented. But yeah, no, being an astronaut is hard to compare as far as job satisfaction, or just it's just I highly recommend it as a career.
The Yelp review from Professor Reisman is 5 stars on being an astronaut.
5 stars. Yep, definitely.
And as I mentioned in the very beginning, when the very few people were there, so we in the master's program, we always have, I would say, 3-4% of students that are coming to the program. Specifically, they work somewhere in the industry or government, and they want to improve their competitiveness to apply to the astronaut training. So this.
I'm constantly, students come to me all the time and want to get advice on how to apply and how to be a good candidate. And I think I need to, I keep doing this like one-off. I think we need to have like an annual seminar where I could just tell everybody at once rather than doing it over and over. Or maybe I should just record it, because it's the same answers every time. But yeah, if you how about that for a little hook there? If you come to USC and you join our department, I'll sit down with you and help you try to become an astronaut. How's
the astronaut tutorial. There you go.
That's right.
Yeah, it's included.
It's included. Might not be one-on-one anymore, but we'll get you some advice.
It'll be there.
By the way, Paul, can I just jump in for a second? I don't know how many of you are following the news, but just 2 days ago, there was a Soyuz launch, 3 astronauts, 1 American, and it's huge news because it's the last time that an American will be launched on a non-American rocket. The American astronauts were launched a few months ago on an American rocket, and that's considered to be not just a one-off now. It's the way the American space industry now is. So we are back. We were the guys in the 60s, and we were the guys during the shuttle era, and we were gone for a long time, and now we're back.
Absolutely. And I believe, I forget her name, but I also heard she's voting from space, which I thought was kind of cool as well.
Yep. Although that's nothing new. We've been doing that for a very long time.
Oh, cool.
Yeah.
That's great.
It works just fine.
Very cool. So I was going to talk about outcomes, but I think Professor Reisman, you kind of hit it a lot, which is where do students go? And you named some fantastic companies. Students are interning at these companies. They go on to get full-time positions at these companies, including more NASA and JPL, et cetera. Is there anything else we want to talk about in result of where students end up going, or any stories you have about that?
I'll defer to Professor Irwin and Grutman, who have seen it for many more years than I have. So,
Well, I've watched
Okay.
undergraduates leave and go away for a long time, and I don't have I don't have precise numbers, but probably the biggest numbers are to the well, we have a large number of graduates that go to SpaceX. We have actually a fair number that go to Jeff Bezos' company, Blue Origin. Um, we have quite a few students that go to the big aerospace prime companies. That would be Boeing, Lockheed, Raytheon, Aerospace Corporation, and um, did I forget anybody? We have a certain number, maybe, I don't know, 10, 15% or something, who go to JPL. And we have a smaller number, maybe 5%, who go on to PhD programs. And we've had actually some pretty eminent PhDs. We have one to Caltech, 3, I think, to MIT, one of whom is now a professor of astrobiology in Colorado.
Yeah.
Allie, right? The guy who went to Caltech is actually a fairly well-known astrophysicist now. He kind of jumped fields, but jumping to astrophysics is well, it's not really a down jump. It's sort of a sideways jump, or maybe some would say even a little up. But anyway,
It's theoretically in a certain direction, right?
well, you can always rotate your coordinates to where it's up.
It's relative.
Yeah.
All right, so I want to get to our audience questions in a minute. So thank you all for holding your questions. We'll get to those in a second. We have time for one last fun question for our faculty, and as you can tell, our guests have voted on this, and so they've all voted for this one question. And maybe as quickly as we can, if you were not a professor, what would your younger self hope you would be doing professionally right now?
Well, I know what Garrett would answer because he already answered.
yep. It was been there, done that. I'm happy where I am right now.
I would certainly be in the science and engineering, and again, to being a professor, it's not a specialty really. The specialty is science and engineering, and science and engineering is very broad. You can focus or be 100% in research and development, and you could be combining this research and development effort with teaching and educating students. It's all this combination, and we are at the research university. That means it means that the USC faculty, they are not only good teachers. As a good teacher you can find in a community college will be excellent teachers, but we are also at USC because we all accomplished certain things in advancing the state of the art of science and engineering. So we are a research university, and this is a tremendous distinction among universities if you explore it further. So we all publish papers, we publish books. If you look at our records on the web, just you can find. So it's a very large number of scholarly publications and books. We participate in different projects, advancing science and technology. And by doing that, we also open doors for our students to be part of some of those projects, to be exposed to these missions, that NASA missions, or some other government work that may not be look that sexy, but it's a major advancement in the science and engineering, very, very demanding things, or for industry to that matter. Because space in the past was dominated by government. Today it's commercial sector in space engineering, perhaps twice as large as the government run sector. And in the government, it's not only NASA. There is a national security component that is twice as large as NASA. So don't forget that. Therefore, try not to do stupid things in your life. I always just tell it to our potential students, and they are sometimes surprised. Don't have a drunk driving on your record and all that, because this may close doors to the very interesting and higher paying jobs in science and engineering in space.
So I didn't mean the question to be fun, but I guess we didn't want to take it that way.
Yeah, well, it wasn't a very fun answer.
I'll tell you, yesterday in biomedical engineering, the faculty want to be Disneyland ride operators and food truck operators, but that's just throwing it out there for. All right, so let's get into these questions. I think Lisa asked a great question here, which is, and I'll kind of paraphrase this: how has COVID affected everything that you're doing, and what is your life like? And I'll just add some prologue to this, which is we are entirely online right now, and we have been online since mid-March, and it's been I think no one likes it. Everyone wants to get back to normal, but I will speak on behalf of all the faculty at the school. They've all rallied in a tremendous way to transition everything online to create fulfilling educational experiences, and also been very creative with some hands-on elements as well. I mean, it's a really, really cool situation and making the best of it. But how has COVID affected your day-to-day, and what's it like?
Well, you're seeing me broadcasting from home. I wouldn't normally be home this time of day on a Thursday. I would be in the office or in the lab or around campus somewhere. So that's perhaps the single biggest change. Some of us are actually doing experimental work. We did get approval to reopen the research labs at first 30% and later 50%. So we had to go through a number of bureaucratic hoops to make that happen. So I actually do go into the lab sometimes and do work, generally not at the same time as the other graduate students. So that takes away some of the pleasure. Part of the pleasure for me of experimental work is doing stuff with other people. I like group work, but we actually try to avoid that now. So we tend to go in on different days. But as far as teaching online goes, mostly, of course, I like being in a classroom and I like seeing people laugh and getting people's immediate group reactions. But however, I do like the idea that I told students that they can just unmute and jump in with questions anytime, and that actually works pretty well. Somehow in a large class, somehow people seem freer to just open up and start talking than they might to actually raise their hand in a classroom. So it's kind of interesting. So in some ways, an online class is actually working better. I mean, overall, I still wish we were in the classroom, but it's not all bad.
Thank you for that.
I think in terms of teaching, another thing that eased the transition for us is that, at least at the graduate level, we teach a lot of classes in a studio. And a lot of our students are distance students. So we have a lot of students that are working full-time in industry and who regularly take classes from all over the country or even outside the country. So like I have a South Korean fighter pilot as a student in one of my classes, and joined me in office hours from Korea. So although roughly half the students in our master's program do attend class in person, the other half don't. So we're kind of used to teaching and looking into a camera, making sure we record and use the technology to our advantage to communicate well and get exams to the students that are far flung. So in a way that having that experience with distance learning going into this has helped. Now that we're all distance learning, I think that made the transition a bit smoother.
Yeah, I would like to just reinforce what Professor Riesman just said. The School of Engineering at USC has the largest national distance education program on the master's level among engineering schools in the country. And this made the transition to this abnormal situation much, much easier, much better than other schools did or other units inside the University of Southern California did, because half of our graduate students are online anyway. So we know how to deal with them, and we simply expanded this experience for now normally on-campus students. Many of them stayed at home, and it helped also to improve, to make it easier to be innovative with the undergraduate classes, because we online, because we have this infrastructure to support distance education. Nothing can replace, of course, the personal contact with students, but again, conditions in our School of Engineering and the Viterbi School is much better than in many other universities because of this tremendous experience of our very large distance education program and the infrastructure in place. Staff knows how to run such a program. It's tremendous help. So we're doing very well on that. and we're looking obviously into the future when we open.
Thank you all. I'm going through these questions, and just for everyone that's asking questions, two of my staff are also behind the scenes typing out some answers to a few of these and handling as much as we can. A good number of these questions we've already actually answered, and so if you missed the beginning part of our chat, please keep in mind that the recording will be available on YouTube immediately afterward on our youtube.com/Viterbi admission page. And so a lot of these have already been handled just because you're asking slightly different ways, but the answer is basically the same. But I want to go to one question here, which is class sizes. Maybe Professor Irwin, you can jump in. Class size, you teach the introduction to astronautical engineering. It's the first year class. How big is your class?
It's actually gotten a little bigger in the last few years. As of maybe 8 years ago, we normally had between 15 and 18 incoming freshmen a year, but it's roughly doubled. So this year we have in the low 30s in the freshman class, and there are a few people who transfer into the major later, either because they've changed majors from USC or because they're transferring from a community college, for example, or from some other school. And of course, some people transfer out, but so overall, the class sizes are fairly small. We don't have to have these very large classes split into sections at the undergraduate level. So we're actually even though we've increased in size, we're the smallest undergraduate major, which means that our department has kind of a family atmosphere. I personally know most of the students, especially if they've been around for a couple of years, and the students get to know our staff members pretty well, and so it's a pretty good atmosphere.
Thank you for that. There's a number of questions that are relating to how do I pick the right major? And I know that there is no answer to this question. I know all of you are going to say there's no such thing as the right answer to this question. But in deciding between this idea of mechanical engineering, aerospace engineering, astronautical engineering, some people think incorrectly that one has better job prospects than another. And so how can we help them understand how they go through this process, and when they're looking, from a distance at these degree programs that seem somewhat similar and they're all relatively interested in them, how would you go about it? Because one of the misconceptions about astronautical engineering, and this is one of the questions, is that it's a niche field, and maybe they might be cornered into something and not have as many job aspects. That's a broad question. I threw a lot out there, but I just want to give you something to chew on.
Well, certainly, if anyone is concerned about being in a narrow major, then don't pick astronautics. Pick mechanical. It's about as broad as you can get. And as I said earlier, everyone needs mechanical engineers. But that said, employers actually don't look so much for the degree on your diploma as what you've actually done and the skills you can demonstrate. And if you show, for example, that you were the lead composites engineer on Rocket Lab, they might not even ask you what you majored in. Really, they want to know what you can do. And as far as that goes, they actually care even a little less about your grade point average than you might think. Now, they don't want to see low C's or anything, but they don't care, for example, about the difference between a 3.5 and a 3.8. In fact, most guys in industry, they didn't get 3.8, so they might distrust you if you get a 3.8 or 3.9. and actually, grade point average, in my view, high grade point average is really better for if you want to apply to graduate school, because there they really do care. So you want to get as high as you can if you're going to be in a PhD program. But for employment, they care about what you've done. And actually, astronautical engineers are really good at building kind of compact, complex autonomous systems that operate in adverse environments, because that's really what a spacecraft is. But that also describes all kinds of other things. I mean, what is an iPhone but a complex, tightly coupled system that operates in an unpleasant environment, like a teenage girl's back pocket, and actually, our students have gone on to quite different majors. I had one student who got to be a pretty good spacecraft engineer, but he had this problem that he was an Australian citizen and he just couldn't make it into the U.S. space industry. And he changed majors to biomedical engineering, and he was really good at it because of the stuff he learned in astronautical engineering. So again, I wouldn't worry so much about the name on the diploma. I would worry about what it is that you want to learn, and as Professor Grumman said, what you're passionate about. I mean, after all, one of the reasons that we have a space-specific major is there was pressure from students that they wanted it to say on their diploma that they were headed for the space industry. They wanted degrees that were space specific, but you don't have to. You're free to change majors, and actually in my introductory class, I try to give a flavor not just of space engineering, but all kinds of engineering. I say, I'll give them examples. Well, a computer scientist would see the problem like this, an electrical engineer would see it kind of like this, and I'll do little things from different majors. And it's happened a few times that people, as a result of seeing those, have said, oh, I really like this digital logic, and they've changed majors. One guy wrote to me, he was kind of embarrassed. He said, I like your digital logic section, and now I'm in electrical engineering, and he was kind of shamefaced about it. I said, don't be. You want to learn early on what you're interested in. So engineering is really great if you're the right person who should be an engineer. Everybody's smart enough. I mean, all of you guys are smart enough. The question is, will you like it? And if you do like it, it's great. If you're not the right personality to be an engineer, engineering's awful. And the same thing is true within the majors. Find what you like. And so try different things. Within astronautics, we have room for tech electives. You can take electives in different majors. You can take majors actually out in the sciences. You can take courses in mathematics, chemistry, whatever. You can kind of branch out and see what you like. And sometimes people that enjoy propulsion a lot and have been good rocket lab people have noticed, oh, you know what? I like chemistry, and they've gone on to be PhD students in chemistry, and they're chemists today. So this kind of thing happens all the time. And people come into the major too. Professor Grumman leads this master's program. The majority of the people who come in to do master's degrees in astronautics were in other majors to start with. They might have been electrical, they might have been physicists, they might have been mathematicians, they might have come from anywhere. So don't think that you're pigeonholed ever. And if you're in a job, don't think you're pigeonholed there. In America, it's not dishonorable to change jobs. That's different, for example, when in Japan, if you work at a company in Japan and then you change jobs, you're kind of damaged goods from then on. They just think you're a little weird and not really to be trusted. But in this country, it's totally honorable, and you usually make more money, and you know, a new outlook on life. A lot of people change jobs 10 times. So
if I can add only one thing, just one of the things, why astronautical engineering has a very unique advantage, whether you call it a niche or anything else. When somebody says, well, one doesn't have to be a rocket scientist to do this or that, you can say, wait a second, I am a rocket scientist. Others cannot say that.
Awesome. Yeah, this has come up in almost every department roundtable session, which is, oh my gosh, how do I choose? What am I going to do? And the summary here is that it's an experiential process. You just start going through it and you start to decide what you like and what you don't like. And from the outside looking in, what do you think you're going to like? And we're not going to like
technical electives is a very important opportunity to probe what is outside your major. Very important opportunity.
So we have started to quickly run out of time, so I have just two more questions for you. One is going to be directed to Dr. Reisman, because you have a few questions here related to your space experience. One was, how's the view from in space? What's it like up there? And what was that training process like to become an astronaut?
Well, the view, you know, it is pretty remarkable. But I'll be honest with you, and I hate to do this because I don't want to dampen anybody's enthusiasm, but it was almost disappointing because, I mean, my expectations were so high. Everybody, you know, I think it was because I was set up to experience something that was going to be really profound, and it was. I mean, it was beautiful and amazing, but it wasn't. I wouldn't describe it as life-changing. Other people have. And for me, that just wasn't the case. But it is great, and it is remarkable to have that opportunity to look at the whole Earth and to fly around and see even places where you've never been and see it from the orbital vantage point. and really just marvel at the beauty of the planet. So the other question was about the training. That a lot of it was really exciting. I mean, flying in T-38 jets and doing like survival training with Russian cosmonauts and the bitter Russian winter and like all kinds of other exotic things that we do. But a lot of it is like sitting in a classroom and studying all the systems on the space shuttle, all the systems on the station. We have, a lot of classroom sessions. We have exams. I remember the first time I took my first astronaut test as part of my training. My wife, who's also a PhD, she's got a PhD in oceanography. So she said, "Ooh, astronaut test. That must be really impressive. I bet there's like lots of calculus, we probably have to solve a bunch of differential equations and it must be really hard." I'm like, well, the first part is matching. The second part is, multiple choice. And I'm really worried about the third part because that's fill in the blank. That's going to be hard, and because it's really, you're being trained to be an operator. You're not designing the space station, you're operating it. It's a very different set of skills and a different kind of challenge. So some of it was super exciting, and being in the shuttle simulator, working with some really capable and highly intelligent people who are throwing the most difficult possible scenarios at you and expecting you to find a way to survive. It's every day is a terrible day in the simulator. And so that's for somebody that likes challenges and problem solving, it was a lot of fun.
Did you get sick
in space or
during training,
or when my wife's driving? When in training, I the only time I got sick was at least one occasion I remember in a T-38 where we did some really advanced aerobatics and pulled a lot of G's and I remember getting sick in the T-38, but in space, no. And all my missions actually, neither myself nor any of my crewmates got sick, and maybe that's why. I think once somebody starts, then it becomes kind of a chain reaction kind of thing. But we all did just fine.
So I mean, we actually have a podcast episode with Dr. Reisman on Viterbi Voices. So maybe my staff can put a link into the chat for the podcast, Spotify, Apple Podcasts, etc. And you can hear a whole almost over an hour of talking about this stuff. Last question for everybody, because as Dr. Irwin said as we got started, the Dodger game is starting right now, and both he and I have to go watch that, and I'm sure a number of you others, unless you're a fan of that other team. But what we want to get into is what's the deal with the differentiation? Why astronautical engineering at USC versus other engineering programs at other schools? Well, the main question that Charles asked was like, how does it compare to UCLA? But I think that's too limited of a question. Why should they come to study astronautical engineering at USC?
Well, I'll give you one answer. It's because of where we are, because the space industry is here. All the big space companies have their, except for Blue Origin, and let's see, Virgin's in the Mojave, but Blue Origin's up in Washington. But almost all the space companies have either their primary or some of their big engineering centers here in Los Angeles. So what that means, among other things, it means you can stay in your regular apartment and get a summer job at JPL or SpaceX or Aerospace Corporation or Northrop Grumman, and it's a real technical job with real money, and it really beats working at Starbucks, I have to say. And our students come back, and one of the things they tell me is, "Boy, I'm sure glad I learned MATLAB from you." And I asked what you did, and they said, "Oh, I'm sorry, I can't disclose what I did." But so being in the center of the space industry is a big thing, and frankly, having a curriculum that's focused just on space, where you're perfectly welcome to go and take kind of side courses in flight mechanics and so on. In fact, they're kind of valuable, but really our students are pretty enthusiastic about space, and we're one of the few places that has a true space only curriculum.
Thank you for that. And again, I want to be respectful of our faculty members' time. We've been going for a full hour now, and I really, truly appreciate it. So Dr. Irwin, Dr. Gruntman, Dr. Reisman, thank you so much for taking this time to talk to our prospective students. If you missed any of this, our YouTube channel has this live, and also it's actually on the same place that you registered for this event. So you can watch the recording at youtube.com/ViterbiAdmission, or go back to the page viterbi.live/events. The recording will be up there probably tomorrow. It's all set for you. If you're thinking about applying for fall 2021, make sure that you get your application in by December 1st. There were a lot of questions related to admission. We put a couple links in there where we can go over specifically all the questions you had about that process, about preparation, the application process, and more on student life. Go to viterbi.live/events to sign up for one of our admission information sessions. We hold those 3 times a week, twice for first-year applicants and one for transfer students on Fridays. So please check that out. Plus, we have all of our other academic unit sessions on those recordings as well if you want to check out the other faculty. So with that, that's it for us. Thank you so much for spending that time with us, and we will say adieu as I head off to Dodger Stadium. Thank you so much, everybody, and have a good one. Fight on, everybody. Thanks, guys. Appreciate it.
Awesome. Thanks, Paul, for this faculty roundtable with the Astronautical Engineering Department.
Have you had any courses with Irwin or Gruntman or Reisman?
So this semester, I'm in a class with Professor Reisman. It's Astro, oh my gosh, why am I blanking on 524? It's
the graduate courses that he discussed in this session, actually, yeah.
Introduction to Human Spaceflight. It's amazing. He's amazing. Yeah, it's great.
Can you provide from a student perspective what it's like to take a class on Introduction to Human Spaceflight, a whole course that he developed based on his experience at SpaceX?
It's so incredible. Like, well, first of all, of course, he was an astronaut, so he'll just like tell amazing stories about super cool stuff. Like he was talking about, I guess you kind of get like a choice meal to bring to the ISS for like a couple. You get it every now and then, like a meal.
Oh.
And I guess he brought candy, so like candy corn and jelly beans and stuff like that, which I would do too, because I'm a big candy person. But I guess it wasn't awesome to have a ton of candy, but no entrees in space. Just stuff like that you can't really get anywhere else. It's super cool. And also, I think, sometimes in engineering, it feels like we're getting into a lot of theory, a lot of equations, and you're like, where does this apply? And so that class has both. And I think the other super cool thing is sometimes aerospace engineering and astronautical engineering can feel like a little removed from people. It's like, who are we building these things for? And this human space flight, totally takes that away. It's really centered in humans, right? Which is super cool. It's amazing. Yeah, it's great. Take the class if you're at USC.
I'll also point out we did an episode with Garrett Reisman 2 years ago now. I can't remember when he started at USC, and it's a really cool and lengthy conversation with him, and he's just a super cool guy. I mean, just reading his Wikipedia page, if you haven't done so, is an entertaining read to get to know him. So awesome stuff. And we didn't even get into in this one, but we did a little bit in our episode with Reisman that I always want to point out is all of his consulting on TV and movies. Like he works in Hollywood. All the favorite space and sci-fi shows that you watch, Reisman's probably in the credits. So we're all super fans over here. So anyways, thanks for joining us today on this little fun episode. We got more, so stay tuned.